So I alluded to this kind of in the last couple videos. We're going to start talking about velocity, okay? And there's two different types of velocity that we're going to be looking at. We're going to be looking at the average velocity, and that's actually quite simple. That's the slope of the secant line. So that means you're just literally finding the slope. So you're doing change in y over change in x, okay? Or y2 minus y1 over x2 minus x1. But what we want to talk about is the instantaneous rate of change, or instantaneous velocity. Okay, instantaneous means it's happening at one point in time. And if you can remember, instantaneous being at one point, that one point is where we're finding the tangent line. So that's us finding the derivative. Okay, so when you're being asked for the average velocity, you're just going to do the slope between the 2 points. When you're asked for the instantaneous rate of change, or just the velocity at a specific point, then you're doing the derivative. Okay, so we're going to try this with a couple of points here. We have this function is our displacement. So the distance a driver above the water level, we're talking about a, I'm guessing a boat that's jumping a platform, right? Okay, so this is, and if you recall, this is again the formula for the path of a projectile, only we're using meters because gravity is 9.8, so that's negative 1/2 times 9.8. Anyway, we want to find the average velocity. So to find the average velocity, we're just going to find the slope between the 2 points. And these are the 2 x values, is what they're giving you here. So where x equals 1 and x equals 2. So this is my x1 and this is my x2. So it's my job to find the y values. Okay, but you can see that I'm using that 1 in each one of my points thereafter. So I'm not finding it each time. So if I substitute in 1 into my equation, I got to find my 2 points, right? So s of 1 is equal to negative 4.9 times 1 squared plus 4.9 times 1 plus 10. And that will come down to your point being plus 1 squared, that's 0, that should be 10. Did I write the equation wrong? Nope, I did it right. Okay. And then I want to find the, when it's at 2, okay? So that's going to be negative 4.9 times 2 squared plus 4.9 times 2 plus 10. So I'm going to grab my calculator real quick and do that calculation. So negative 4.9 times 2 squared plus 4.9 times 2 plus 10 is giving me 0.2. Okay, so for, this is letter I, by the way. For letter I, my slope or my average velocity is going to be 0.2 minus 10, that's my second y, minus my first y, and then my second x, 2, minus my first x, which is 1, and I'm going to do that calculation, which is negative 9.8. So that's going to be meters per second. Okay, so then if I'm looking at the second problem, I already know my 1. Okay, so I have the point is, this is my x2 is 1. So that means my y2 is 10. So now I got to figure the other one. So I need to find s of 1.5. So I'm substituting in negative 4.9, 1.5 squared plus 4.9 times 1.5 plus 10. And I'm going to type that all in. So, oops, 1.5 goes there. And 1.5 goes in that x. And it gives me 6.325. Okay, so for this one, I'm getting my speed is going to be 6.325 minus, oops, I'm doing that backwards, aren't I? That's my 1. I want my 1 first. Okay, let's take my 2. So 10 minus 6.325 divided by my, they're kind of giving it to me in a weird order. I think that's what's screwing me up right now. But anyway, and then my x's are 1 minus 1.5. So that's going to get me 10 divided, not divided by, minus my last answer. And that's divided by 1 minus 1.5, or I just could have typed in negative 1.5. I think that's what I'm going to do because I screwed up the parentheses anyway. And that gets me negative 7.35. Now let's look at what's happening. So it's saying my average velocity here, okay, remember velocity is just speed, but not the absolute value of speed. So it says my average velocity is negative 9.8, okay, and the negative actually tells you a direction. So my speed is actually 9.8, my velocity is negative 9.8. Here my speed is negative 7.35. So my speed is 7.35, my velocity is negative 7.35. The negative is actually saying that the thing is that the slope of it is negative, okay? So that means it's coming down. So it looks like it's actually slowing down as well, okay? So we'll go on to number 3. Okay, and number 3, we only need to, we have the second point, which is 110, and we need the first point we have to find at 1.1. You can see we're looking at smaller and smaller intervals here, and so that's what it's trying to get us to look at. So I'm doing negative 4.9, and I'm putting 1.1 in for those values instead of 1.5 now. So delete and put 1.1, and then delete and put 1.1, and I'm getting 9.461. So that means I'm doing 10 minus 9.461 over 1 minus 1.1. Okay, so 10 minus my last answer, and that's divided by negative 0.1. And I'm getting negative 5.39. So we're following that same pattern. It's still a negative velocity, but the speed is less because we went from a speed of 7 to a speed of 5. So the last one here, what we should expect to see a negative number as well, I would think, but something closer to 0 than 5. Okay, so again, we're using the point 110 as our second point, but this time we're looking at S of 1.01. And so I'm just doing a little copy and paste in my calculator and putting a 0 in. Make my life a little simpler there. And I'm getting 9.95051. So I'm doing 10 minus 9.95051 over 1 minus 1.01. So I'm going to do 10 minus my last answer divided by negative 0.01, and I have negative 4.949. So there are our average velocities. It's actually going to be harder finding the average velocities than finding the instantaneous velocity. So those are my 4 average velocities. I'm going to erase the screen to do letter B. Okay, so let me go ahead and clear those notes. Okay, so letter B says find the instantaneous velocity, and what we saw on the last screen is instantaneous means that we're going to be finding the derivative. So my original function is negative 4.9t squared plus 4.9t plus 10. And let me find the first derivative, because that's the velocity. I'm going to bring the 2 down and multiply by that, and that's negative 9.8t plus 4.9. And to answer the question, at t equals 1, because that's what we were heading towards, was that distance was all heading towards the number 1. So let's find the derivative at 1. We're going to see that it's going to be close to that negative 4.9. So negative 9.8t plus 4.9. Oops, I should actually just put that 1 right in there, right? So let's put that 1 right in there. And you can see that what we actually get is negative 4.9. So that's the speeds precisely at when the boat is at 1 second in its ramp, basically in its jump. So after 1 second in its jump, it's going at a speed of 4.9. Its velocity is negative 4.9. Okay.